For the second page of 3-16, we're looking at a graph about the growth of a subscriber base, which is subscribers to a mobile phone company. And first of all, this is a bar graph, so that's a little different than the graph we had on the previous page. But we also want you to notice that the way the graph is growing is a little different. There is a curved shape to this that's different than the linear growth that we saw here. This grew in a straight line. And over here we have, it could almost look a little bit straight here, but then you can see that it's getting steeper and steeper and growing more quickly over here. So what type of model does this look like to you? Hopefully you'll guess that it's exponential growth. How could you confirm your answer in Part A? What calculations can you do to support your answer? Well, when we have exponential growth, we are going to see the same percent increase every year. So what we would want to look at is calculate the percent increase and then calculate maybe between these 2 years, and then go over here and calculate the percent increase and calculate the percent increase a few times and just see if the numbers are the same. The amount that it increases is probably not the same. This is looking like a 10 million subscriber increase. By the time we get over here, it's just under 100 million subscriber increase, and over here it's over 100 million. So definitely this is not a linear model. A linear model has the same amount of increase every time. So what we need to find out is if this is the same percent increase, and then it might be an exponential model. So let's write some of that here. The curved growth looks like exponential growth. This definitely isn't linear growth because the amount of increase is not the same each year. At first, there is an increase of about 10 million subscribers, but later the increase gets much bigger. Okay, how can we confirm our answer in Part A? What calculations can we do? Well, let's do some calculations. Let's find the percent increase for 2000 to 2001, and then we'll do it again for, let's do it for 2009 to 2010. Okay, so the formula for percent increase is the amount of change divided by the original amount. So for 2000 to 2001, for that one, the amount of change will be, we have to take 38.8 minus 28.5. That'll give us the amount of change, and then we divide by the original, which is 28.5, and then we'll multiply by 100%. So 38.8 minus 28.5 gives me 10.3 divided by 28.5. Times 100% gives me 36% increase. Now, if I do this process again for 2009 to 2010, and it looks like this is what I was supposed to do down here, so I'm going to take this and go do it below. Okay, 2009 to 2010, so that would be 617.6 minus 454.1 divide by the original amount, so 454.1. And when I do that, and I multiply by 100%, I still get 36%. That's interesting. It was a much larger increase, but relative to where we were at the beginning, it's the same percent increase. So let's also do this yearly percent increase. So that will be 52.8 minus 38.8 divided by 38.8 times 100%. 52.8 minus 38.8. I'm sure you can do this yourself. And I get exactly, well, I get 14 over 38.8 times 100% gives me 36% increase. Now, it would be pretty unrealistic to actually have a real data set where the percent increase is exactly the same every single year for a long period of time. And I told you up here that the numbers are fictional and they fit a model more perfectly than we would expect to see in real life. So we'll have messier data in the future in other examples, but for now we just made a really clean example to illustrate the point that with exponential growth you're going to see the same percent increase every single time. When you have this situation, then we can talk about the growth factor and the growth rate. In exponential growth, each output is found by multiplying the previous output by a growth factor. The growth factor is B equals 1 plus R. The quantity grows by the same percent each time. R is the growth rate written as a decimal. So in our example, the R is 0.36. Because we had a 36% amount of growth, a 36% growth, we convert that to a decimal, and that's our R. And then the B is 1 plus R, so 1 plus 0.36 gives us 1.36, and this is our growth factor. This is the number you can multiply to get the next output, the next value or output. So what is the growth factor for this model? We just found it. That is, what number do you multiply the previous day's, we shouldn't say population, we should say subscriber amount, to get the next day's, or the next year's subscriber amount. I must have made a mistake here. Okay, so we already figured out that B is 1.36, and then we're going to try that on the data. So this means that you would take 28 and multiply by 1.36. And that should get us to the next value. Try that, 28.5 times 1.36. Well, that would round off to 38.8. So that works. And then let's try it again up here. If I take 132.7 times 1.36, does that give me the next value? Yep, 180.5. So a quick way to increase by 36% is to multiply times 1.36. And that's a shortcut that you can do for tipping. You can multiply your total, your bill total, by 1.20 to get the total amount of your total plus your tip. The next item in a box says that if A is the starting value and B is the growth factor, you can write a model. So just like we can write a model for a line, we can write an exponential model for a situation as well. Write an exponential model where Y is the number of subscribers and X is the years since 2000. what we're looking to do here is to say y is equal to, and then put down the starting value, because it says a is the starting value, b is the growth factor, so times, our growth factor in this case was 1.36, and then we put x in the exponent, because we're going to be multiplying 1.36 many times as the years go by. So all we need now is to go back and get the starting value. That was 28.5 in 2000. And since this says years since 2000, that's where we're starting. So I put 28.5 right here. And that is my exponential model. It's a little bit messy, so I will rewrite it down here. Y equals 28.5 times, I can put a dot or a parentheses, 1.36, and then to the x power. So question F says, how many subscribers will there be in 2018? Write your answer in scientific notation. Does that mean we're going to have a really big answer? Well, in 2018, 18 years have gone by. So we take that starting amount and we multiply by 1.36 over and over and over again. So 18 will be our exponent right here. If x is 18, then y is equal to 28.5 times 1.36 to the 18th power. And when I put that into my calculator, I get 7220. And that doesn't seem to need to be in scientific notation. But then I remember, oh wait, this graph was in millions. So I have that number, but then I need to put the word millions on the back of it. And so then you can imagine why we might need scientific notation, because 7220 with 6 more zeros on the back, because I multiply by 1,000,000 subscribers. So that's going to be 7.22 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9 subscribers. That's the amount that I would have in 2018.